Alright, silly people, here's the situation. We're going to be doing the same thing that we did for the last couple of videos, except we're now trying to find the ground state and the first three excited states for the infinite square well, which is this sort of differential equation here, which by the same method as before, you can define a variable chi, which is the first derivative of psi, and then you can rewrite the ODE like this, so it's a first order ODE, and you can solve it via Python, right? The solutions for this tend to hang around k equals n pi over b. So what we're going to do is we're going to take our old code from the last problem that we did, paste it down, and we're going to change the differential equation because now it just reads k squared times psi, and we're going to fix b, which is going to be the length of the well, to around pi using numpy.py, right? And also this should be b and this should be a. So that with that in mind, k is going to be just the integers 1, 2, 3, and whatever. So for the first, or for the ground state, I guess, we're going to start with 1, and it's going to be lowercase k. It's a different k. Let's actually look at 0.9 and see what happens. Oh, and by the way, we need to be looking at the case so that, psi of 0, no, psi at pi has to go to 0 roughly. So let's check that out just by honing in on minus 0.25 to 0.25 to see the cross. I think this is a little high. Maybe we'll take it down to 1. Yeah, so it seems to go to 0 at pi. So maybe 0.99 was too low. Maybe we'll go to 0.99. Or what about 0.999? Or 9999? Or perhaps even 0.9999. I can't really see if it's crossing 0, so I'm also going to plot a line at 0 here. Just saying plot sol.t versus a 0 array, so np.zeros, that has the same shape as the length of the sol.t. It is kind of crossing 0 a little bit too far here, so let's take this number and make it like 0.9998. That's still a little bit too much. What about 0.9997? Or 6? That seems to be better. Let's add another digit though. We do need it to like 5 digits. But I think 0.99969 is a probably good enough solution. Yeah, but it's still really close to 1, so it's what we expected. So that's the ground state out of the way. And by the way, you can convert these numbers to energies, right, just using the formula for the infinite square well, which was all the way back. It's equation 2.3 or 2.30 in Griffiths. You just plug in n squared pi squared h bar squared over 2ma squared, where a is the length of the well, so that you can get the energies. I'm not doing that though. I'm just messing around with k's. So again, first excited state, this is going to be around k equals 2. So I'm going to say 1.9 first and see what happens. It doesn't quite make it all the way to the cross, so let's add another 9 and another 9. So now it's sort of there already. What if we add another 9 though? It still doesn't quite cross, so that's fine. That's 5 digits already. We can be proud of that result. Next is the second excited state, which is going to have a k around 3. So let's try 2.9 first and see what happens. Doesn't quite make it to the cross, so let's add another 9 and another 9. That kind of crosses over a little bit, so let's back off. that number a little bit. Just honing in on what this value should be. Maybe we won't have the second to last digit be 9. Maybe we'll have that be 8. But then we can put a 9 here, and it still it crosses over a little bit whenever I do that. So what about 5 or 6 or 7? 7 seems good. Okay, 2.9987 for the second excited state. Finally, we'll do the third excited state. So we'll take this guy, and then the third excited state will have a k around 4. So let's try 3.9. That doesn't quite make it. Add another 9. That doesn't quite make it either. Add another 9. That is right on the money. Maybe let's add another 9. It crosses over a little bit, so let's back off. That seems fine. Somewhere in the middle there is the money spot. I think it's 3.9998 for that. Okay, funny little problem there.